So again, in this particular video we'll show how to modify a Simulink model so it can be used in the parameter optimizer to find the parameters of the system. So we'll just make a simple RL circuit, and the objective is to find the resistor and inductor value. Okay, so because we'll be using Simulink, we can put equations like this in S domain and then solve for the current. So we can solve like this, and we can do the circuit then and get something like this. So you have the voltage here, resistor times current is subtracted and then multiplied by 1 over Ls, and you get the current. If you go to options, here's the information about the circuit, the voltage, frequency, resistor and inductor value. We can press play and we can see the results. Here's the voltage, here's the current. So what we have to do now is, again like with the PSpice model, we have to do two things. We have on one hand to write the outputs to be saved. That's the outputs you want to save because you will use them to plot, and you will use them to plot against experimental data to find the true values. And also you need to modify the model in such a way that some parameters are treated as unknowns by parameter optimizer. So let's do that. If you read in the help, it explains exactly how to do it, but let's do it in this video also. Let's start to follow the same order with the output variables. So what you have to do is you have to find save to workspace block. Here it is. And what this block does is default settings like this time series is what you have to put, and you have to leave the name SimOut also. So basically default settings are okay. What this block does is it saves to workspace variables that you want from a Simulink model. So in this particular case, we'll use the current as a measurement of we'll compare the currents to measure the error and find the true parameters. So what we want to save is time and current. I'll also save, yes, for the sake of it, the voltage, but we don't need it in this model. So what we do now is we just put a multiplexer. We put as many inputs as variables we want to save, and in this case you have to note we also want to save the time, because we'll plot current evolution over time. So what we do is, as explained in the help, is we put a clock block, and that's it. So we put, for example, as the first variable to save. This is again the same as PSpice when we said we have to open the out file and check which column is which. You can see it here visually. First variable to save is the time, because I put the clock block. Now I will save the voltage for the sake of it, so I'll just drag it here, and then I will save the current. Okay, so this model now, if you save it, you run it, it will save to Simulink in a SimOut file all these three variables in this particular order. So last thing you have to do is you have to put the unknowns, the parameters. So the way to do so is Simulink will create a new vector called P will be created and is accessible from Simulink. And this P vector is similar to bar param in PSpice. What you do is you basically access each variable by access the index of the vector. So what we'll do here, if you notice, I have the resistor and inductor is what I want to estimate in this case, and I have R and L. If you go to properties, you can see they have some value, but they must be unknowns now. So what we do is simply, we'll just say, for example, because we have to maintain always the same order, resistor will be the first parameter, so we put P, parenthesis 1. This way we access the first element of the P vector. And then inductor would be P2, and that's it. We can save, and that's it. That's the two modifications you have to do to your model. Then I will show you very fast the program running the simulation and solving, because it's very fast. You can see in real time. I have created this configuration file that you could learn how to do by following the video where I explain so, but basically it's the same as always. You can see it from the wizard. You're more comfortable. Okay, so here I'm saying again, like this is data file. I kind of cheated a bit. This data I'm using in this particular model, it's not from some kind of lab. I just did a model in Simulink. I put some parameters in the RL. I simulate it and save the data, and then I treat them as unknowns, and I want to find them and see if I find the same ones, which it will. So I put here the location of the file with the data for the current over time, and I save it when I can open it. I save in the first variable time. You can see it's going slowly up. Second variable is the voltage, and third one is the current. So I will plot in the x variables will be the time, and the y variable will be the current, and because of the column order is 1 and 3. And I simulated from 0 to 0.04 seconds, so that will be the segment I want to use, and number of points, for example, 100. Then same for the model. I pick the model, here it is, and again, because in the CMOUT, you can see first one's time, second voltage, third current. I want current over time. X variable will be the time, which is the first one in CMOUT, and y variable is the current, is the third variable in CMOUT. And then finally, parameters, like just using the plus buttons, I add the two parameters I want. Again, following the same order here, as I said before. Resistor will be the first one, inductor second one. So I do the same here. First one resistor, second one inductor. And I put initial value of 0.1 and 1 milli here, and some limits. And it will try to find with this information the true value. So let's see if it does that. Okay, I have them here. I'll open it again. This is a configuration file, and here's the same data using the wizard, yes, in the text format. A bit harder to read, but it's the same. So we press run, and we can see here the evolution of how the parameters changed. And here you can see the estimation is getting closer to the blue one, which is the one you want. The red one is the initial one. You can see over time how it gets better. This is the error. You can see it's a proportion of the error, so if you multiply by 100 you get the percentage. And it started with 167% error, and it's already like down to less than 1. You can see now it's almost perfect. I can barely see. And you can see here the parameters over time. You can see how it went to 0.5, which is I mean, it's the value I had put 0.5 to milli. You can see it goes exactly to those values, and the error is almost 0. You cannot expect this kind of data fit from a model with experimental data, but still you will still get really good a really good fit as long as your model is okay. And last but not least, I can give you some tips regarding if you need to use models where you use they depend on the time. They are always a bit tricky. So there are two things I could give you as an advice, because I have been working with PMSM, and I have found some problems that can be solved, that you may encounter if you need to use the time in your models. First one is you need to synchronize things. So if you have a model where you apply some voltage at some time, same time has to be applied both in the experiment, both in the model. So what you do is basically you don't complicate yourself, and you do a model. You put the signals where you want, and then in experiment you follow the same let's say delta time, and then you do a shift. That way you ensure that time like you are doing the same things at the same time. And then you may also encounter problems if you have models that depend of previous instance. For example, if you have an electrical machine, the current depends of the previous current. So you have, let's say, two options. um, you can try somehow to with another circuit to initialize your current to, or not really a circuit, maybe you don't need a circuit, but you can try to initialize your current to the same current that you have in the experiment when the same current that starts in the experiment. The only problem with that will work more or less fine, but it will only work for a short period of time. The reason is that if you think about it, if you have a model that depends on the previous instance, you're using your model to estimate what will happen next, and you are comparing that with experimental data. You can clearly see that a really small error, not let's say in the parameter, which also, but in the model, because the model will be good, but it will not be perfect. Also, experimental data will have noises. A really small error will pile up over time. So if you have a model that depends on the previous variables, you always have to be aware of that. So if you simulate in a short period of time, like what sort, it depends of the system, but let's keep it simple. If you simulate in a short period of time, it may be okay to just initialize your variables to the value they must have. But if you simulate for a long period of time, so it's, for example, I simulate for several seconds with my machine, you can see that if you try this way of just initializing the variables, it will not work because the errors will just pile up. The way to solve this problem is you just have to modify the models in such a way that it's a bit complicated, but you have to modify your models in such a way that in each period, let's say in each period k, you predict what will happen in the next period, and you use that prediction, you compare it with the experimental data, but at the end of the period, that prediction that you use, you change it back to the experimental data. So you have like let's say 2 states, and that way, because let's say in each period you are predicting what will happen next with the experimental data, but that prediction you use it to compare with experimental data, you will not have this error where small modifications, small things will pile up and destroy your fit. This way I managed to use it to estimate the machine parameters of PMSM with less than 1% error. So it's something that definitely works and is the way to go. And a more general approach would be to modify simulation engine in such a way that you have these 2 states, like you would have an update method and a late update method, maybe for example like you do in game development. But that's another problem that takes a lot of time to do, and basically you have to modify it like this. That's my tips. So hope you find this video useful. If you find some problems or have any doubts, just go to the website. You also have more information in the help button. In model creation, you have here all the information how to create a PSpice model, also how to modify a Simulink model, which is more or less the same I said here. So thank you for your time. Hope this video is useful for you. Bye.